Hello, thanks for coming. I have the pleasure of, apparently not yet. Turn it on. Hi, thanks for coming. I have the pleasure of introducing Gilad Bracha. And Gilad, turn it over to you.
Okay, thank you all. Good afternoon, and thank you all for coming. Hopefully you won't find out you made a terrible mistake. So a few words about this talk before I really start. Essentially, this is a slightly evolved version of a talk I gave at UPSLA at the Dynamic Language Symposium in October of '05. But the history of it goes, the reason I'm mentioning this is because the history goes back a good deal longer. I started on this topic in late April of '04 when I got my Gmail account. And I used Gmail for about half an hour and concluded that there were interesting issues that I cared about that were worth exploring. So what is this about? At a high level, it's about bit rot, or rather the absence of it, and my goal is to introduce it. So bits are these pristine bits of information, right? They never corrode. You cannot spindle or mutilate. They never rot or crumble or anything. And this is often perceived to be a good thing, and at some point I'm going to argue that it's a bad thing, because when you have physical objects like your car, it does rust and break and fall apart, and you get to get a new one. And the problem with software is you never really get a new one. And so you're stuck with all this old crud that lives forever, like a vampire sucking your blood. And this is partly about a way of getting away from this trap of having everything always compatible till doomsday with whatever mistakes you made before. And in particular, I'm a language guy, and this is a language talk at some level. And in particular, there are certain things about dynamic languages that can help us rot the bits. So concretely, software requires maintenance. Software has bugs. People expect them to be fixed. Should you ever reach that happy day when you don't have fixed, they'll complain because you don't have new features which will enable you to introduce new bugs and renew the cycle. And online update is becoming more and more widespread, of course. It's standard practice among operating system vendors and among the antivirus vendors who live off at least one operating system. And let me show you what this looks like on my operating system. So the first thing it does, it nags. It says, please, please, can I update? Listen, I really, really need to update now. And it bugs you. And then finally you say, very well, machine, you may update. At which point it turns around and acts pricey and tells you, show me your ID. Show me you're worthy enough to update. And then, OK, you put in your password and you think you're done. But of course, you're never done without this. Never, ever. And OK, few people know that below this line, it says you promise your firstborn child to Apple Computer, or Apple Phone, as it is known nowadays. But that's what it actually says there if you ever scroll. And so you've promised your life away. And then this is really the annoying thing, right? Half the time, it wants you to restart. It wants you to stop whatever you're doing, interrupt whatever work you're doing. It goes off, it shuts down all your windows, churns, and comes back again. And this is really one of the things that annoys me. This whole restarting business, rebooting business is a plague. We instead of realizing that computers should not reboot, we're making this worse, because now we have phones that are really computers and they need to reboot. And if you have TiVo, your TV needs to reboot. It's a plague. And sometimes it can get worse, right? This doesn't happen that often, but something can go wrong and it won't let you restart because you have another user log on or whatever, or some process won't. I'm going to ask that you hold the question. I've given this talk a whole bunch of times. What I've found is, and I've done it both ways, if you have, it raises a lot of questions, and if you take the questions in the end, there's a timing disaster and you never get to the end. Whereas if you force the questions into an narrow slot, people can stay later. And in fact, a typical scenario is that the questions take as long as the talk. But it's better to keep the questions to the end if you don't mind. So anyway, obviously there's room for improvement. So overall, we'd like things to be better. We want to make the maintenance as transparent as possible. And notice I'm saying as transparent as possible, but not transparent. I don't think actual completely transparent, maintenance is a good thing. And I'll explain why in a few minutes. But basically, we want to minimize the questions, the hassles, the problems, and nothing should ever visibly boot or reboot or any of this stuff. That's in general something I believe too. If you can do it in 300 milliseconds or less and come back to where you were, that's OK. That's your mechanical problem of restructuring. It shouldn't. This is not something that interests people. Physical objects don't reboot. But you do want it to be always up to date. You do want that maintenance. You do want the bug fixes, et cetera. And so this is a lot like a web application, something that some people in this room might actually know something about. In fact, that's the big risk of talking here, is there might actually be people who know what I'm talking about, and who knows what trouble I'll get in. But web apps have downside. Now, this is perhaps where I really get in trouble here. Right? So obviously, one problem is the system software can't be a web app. The operating system, the web browser, all the major plugins in the web browser, the things that show you your photos, your videos, et cetera. And indeed, the web browser follows the same model. It nags. Then it asks inane questions. I love this. You have chosen to open a Firefox 2.0.0.1.dmg file, which is a DMG file, in case you didn't know. And what should Firefox do with this? You're asking me? You just asked me a minute ago to do this, and all I wanted was to upgrade to Firefox 2 for improved security and better browsing, yay. And now it's asking me what it should do. The people who sit in front of this aren't all people who work for Google, or even people like me, right? Your grandmother could be using this, your 5-year-old. An executive could be using this. What are they to do? What does this mean to anyone, right? These hassles have to go away. So then, of course, you need a bit of patience. And this is sort of premature gratitude. Thank you for downloading. Your download will begin shortly. So shouldn't they wait till it downloaded before? Well, anyway, I'm just being petty. I understand where this comes from. And then you wait a bit more, because it's huge. It's 18 megabytes, because the whole bloody package has to be, because they've updated something. And you can't live without that. And then there are various hassles, like you actually have to install it yourself, and you forgot to move the file. And when you try to move the file, well, you can't do that because Firefox is in use, right? Again, the restart thing. Everything has to shut down. Nothing actually can update itself without shutting down. And more hassles. So there are other downsides, of course, to the web apps, apart from the fact that the system software can't use it. There are UI issues, and yeah, that's getting better, and this whole Ajax thing. But I started on this issue when I used Gmail 3 years ago. I don't see that things have radically improved. Some tools are better than others, but basically, I think there's a real problem both on the user side and on the developer side with that model. But that's relatively minor. The big problem, of course, is that this actually depends on having a robust, low latency, high bandwidth network. That's cheap, by the way. The cheap I added after my experiences in various airports. My favorite was in Heathrow, where T-Mobile had this link, US subscribers go here. And I said, oh, I can use these goddamn minutes somehow. And then it told me that, for 10 pence a minute, I could roam the internet from London. And, the level of gouging is beyond belief. And yes, I know it's live. And the other thing is, of course, you really haven't solved the reboot problem, right? The sessions expire. You still have to start up every now and then. And it's not just system software. There's a whole world of applications which could benefit from being kind of a real live application locally. To take an example that some of you might be familiar with, obviously there's all kinds of reasons why there is a download, but it's a very nice application. It's fabulous. But it still follows the pester and legalese sort of model of things, because that's what the current state of technology lets you do. So what is software services is this generic phrase, of course, that everybody uses for whatever. Unfortunately, I haven't quite come up with a better one. But what I mean here is, of course, something that combines the advantages of web applications and traditional applications. And in particular, it has offline capability. It's always available even when there's no network. And it is still always up to date. It updates itself over the network nevertheless. So it's running locally, but it is network aware. And in particular, and this is one of the things that distinguishes this from a long line of, in particular, all kinds of startups out there that were in the 2000 time frame, a few of which I think are still alive. The thing is that restart free is very, very important. I don't actually want to shut down applications in order to get these updates. I don't want to go through any major hassles. I want it almost transparent, but not quite. So how are we going to do that? Well, hot swapping is just a sort of a pithy name for the process of modifying the code live while it's executing, which has a very, very long tradition in a long list of languages going back to APL and Lisp at the dawn of time through Smalltalk, Self, Erlang. Not coincidentally, this is a list of really cool languages. So, of course, hot swapping, OK, this is traditionally done in the development environment, and it's great, and you can patch your code while you're developing and debug and all that. But doing this in production makes some people a little bit edgy. There are technical issues. There are other issues. One of the most interesting technical issues is this one. Suppose you've modified the body of a function or method, and there's still actually live stack frames. What the hell does this mean? Both in terms of A, what do you expect the system to do? And B, what does this mean for your application? What was the meaning of the program you wrote under these circumstances? Then there's, this is basically a solved problem, but it requires some engineering to deal with. If you've got an object-oriented language, you've got instances on the heap, and you've added fields, removed fields, invariants have changed, and what happens to these instances? And there are good solutions for this, I think. And then there's a small matter of security that some people fuss about, though it's remarkable how little, but we're still waiting for Cyber 9/11, at which point maybe people will start taking it more seriously. So what do I propose to do about these problems? Well, first of all, this process of reflective update through hot swapping, it needs structure. And it so happens that I have a structure that's been used, which is called mirror-based reflection. And I'll talk a little bit about what that is in a few slides, which I believe can address a lot of the security worries around this thing. The other interesting problem is indeed the stack. And it is, of course, a lot easier if the program isn't actually out there computing something with a stack. If it's not doing something, if there isn't much of a stack, life is a lot easier. But this doesn't mean shutting down the program. So what does it mean? Well, observe that a lot of the kind of applications that would benefit from this model are actually, they synchronize something. Maybe they synchronize with a computer. Maybe they synchronize over the network with a server. They're already going through a process of reconciling their data with some copy somewhere else. And this it turns out to be a very convenient thing for these applications. Obviously, synchronizing with a server has all kinds of benefits. Putting things on servers, I don't need particular lecture you what the advantages are. Some of the major ones are written here. And I have this nagging suspicion that you're aware of that. But synchronization is a very natural point to do this kind of program update live. The applications are quiescent. If you're actually, we're talking mainly about user interactive client applications. If you're about to press the sync button, or you could set it up to sync every hour or some such thing, right? It's not doing very much else necessarily for you at that point. It's very natural. It's a hiatus. And there's plenty of time with any interactive application when the users aren't doing something. The advantage of that is there is no stack. There's maybe at the bottom of the stack, there's an event loop. And depending how actually things are structured, maybe there isn't even that. Because maybe it's actor-based and the events are sort of every actor is actually waiting for something to happen, and none of them actually have stacks, depending how you do it. So the point is, that makes that particular nasty technical problem a lot easier. And equally important, the transition is user visible but very lightweight. Right? When you sync, say, a calendar application, you're not going to be shocked if something new appears. You're going to get new calendar entries, new address book entries, whatever. By the same token, you could actually get new menu entries. Maybe now there's a dictionary or a spell checker in your word processor, or some feature that wasn't there before. Or maybe some bugs are fixed, or something looks a little different. But it's not, you can't have things change under people's foot like totally transparently. But this is very, very lightweight. They don't have to answer questions. And most they have to press a button. For executives, there's the mode where it just does that every hour or something. So this is all based on the idea of program as data, which is, of course, another very old and classic idea. And really, the idea here is to sync the program as well as the data. And in a well-organized virtual machine, your classes and stuff are objects in the heap, just like everything else, and it actually really works out that way. So the next thing is, again, to make that easy for people to write applications and do that. So the model here is, again, software as a service. You're syncing up. Someone's providing you this service with backup and all this stuff on their server, and you have an account, and you synchronize. And when you synchronize, you get the applications that they provide, and you update your data, and it gets backed up, and they push bug fixes to you every time you synchronize. Just to be a little clear as to what the general model here. Now, once you're doing that, you want to make it easy for people to actually write these applications. Now, it's never easy to write good applications, but you want to make it easier. So the idea here is to basically start with some set of persistent routes, things that have to persist on the server, that have to be synchronized. And of course, do the usual heap traversal and find the subset of the heap that actually is persistent. And you cut it off by marking certain fields being transient, because not all your data in your running application is really something you want to save. And every sync, you basically traverse this, collect this data, and send the changes from the last time over the wire. So again, you're not sending 18 megabytes of Firefox necessarily. You're changing what changed in Firefox, today. And hopefully that's very little if you do this on a very frequent basis. And so these things don't take up time. They're not disruptive, et cetera. Now, transient data, of course, the transient data in your application might just happen to depend on the persistent data. And so if you've changed your persistent data, your transient data isn't going to be good anymore. And so you really need to zap it on every sync, basically nil out any transient field. And make those fields lazy so that when the next time somebody actually needs that data, it gets recomputed. So you can enforce this language-wise by, say, having something that looks vaguely like this, right? If a field is marked transient, it has to be followed by a closure that says how to initialize it. And whenever it's nil, that'll be called. And that doesn't mean you can't get into all sorts of trouble and whatever. You do still have to think about what that code is. But that will actually let you update yourself, get rid of any transient data, and that transient data will come back on an as-needed basis and not be massively recomputed all at once, which is sort of what tends to happen in some of the languages I've worked on in the past. There may be a need for another level. There's one of the natural questions is, window handles, network sockets. There's things like this that really aren't part of the data you need on the server, and yet you don't want to zap them on every sync. So maybe there's a session level, or maybe your platform actually knows about these in some way. There are a couple of strategies, and I don't have a whole lot of time to discuss them, but there has been work on actually bringing these things back without losing them. Now, people who were sort of in the programming language world know that this is very reminiscent of a thing called orthogonal persistent that had some problems and was heavily criticized. And this is really my high-level point, but I actually will bother to back it up. So the problem with orthogonal persistence, that was the idea that basically, again, not talking about synchronization as such, but saving stuff persistently to the disk automatically based on marking some routes in your program as persistent. Well, one of the complaints about this is, well, this sounds all neat. You don't have to worry about databases and saving and storing and all that. But in reality, what happens when data tends to be long-lived and it outlives the program? So imagine I had orthogonally persistent Fortran, and I had this priceless scientific data. And now, of course, my orthogonally persistent Fortran only runs on a machine in the computer museum, and the termites have eaten all the insulation, and we can't run it even there. And now, the solution to one of the great problems of science has been lost. This doesn't apply here, because the key here is that the program and data are living together as part of this service. The service bundles the data and the programs that operate on them. And as long as you're subscribed to the service, you have this data. And every time that data is updated, or every time the program is updated, they update in lockstep. Now, there may come a day when you want to shut down the service, and then hopefully your contract says that you can get this stuff out as files in some format. Someone should remind me how I get my mail properly, easily out of Gmail. But maybe you can get away with selling this stuff without providing that. The other issue that comes up is, of course, that there's transient data. When you do orthogonal persistence in its very simple classic form, there's transient data that pollutes the database. There's stuff that's in there that represents things about your algorithm state you need to store that really isn't really part of the real business objects, if you will, that need to be stored. And that's been solved actually in the orthogonal persistence world already, right? These transient markers basically say, this is transient data, don't bother with it. In fact, it gets zapped at every sync. Another important point is that if you do that and you don't save your data through a database or something, they say there's no cross-program interchange format because the format you're storing things on the disk is some sort of image of what you have in your running process in your program. And much as I hate this answer, smell, it is pronounced smell, isn't it? Some people pronounce it XML, but a lot of things like, Zool, X is kind of hard to pronounce, and I find that fitting. So there is a fairly standard way to deal with these things nowadays, and it's sad that this is the way, and rather than say S expressions or something, but it's there. You're going to need this with any kind of web-enabled thing that'll be, talking to web services, and so there is a way to extract this. So to summarize the key points up till now, dynamic typing, which really makes it a lot easier to do this hot swapping. It isn't a coincidence that this only works in dynamically typed languages, and that it's an active research topic with not many convincing results in statically typed languages. It's not that it can't be done. It's a fine topic if anyone wants to do a PhD, but it tends not to be done because it's just bloody hard, and it's a distraction. Once you do the hot swapping, you can do the orthogonal synchronization. That is, you can update your live process without shutting it down. And that's the basis for this notion of a nice service that gives you these applications and incidentally syncs up and provides storage and all these kind of things. So then let's talk about this small matter of security. So hot swapping in production already gives people the willies. So doing it over the network is just there for extra fun. So there's several things that are obvious. You have to verify the identity of the server. Well, that's not particularly new. Every time Microsoft updates your PC or in a better case, Apple updates your Mac, which actually works, you'd better be sure that it's them and not someone else messing with your machine. So there are SSL and so forth. There are protocols for doing that. You also have to verify that the clients are who they say they are, because now they can they can upload bad data and mess with you. They can access your data. They can change your data. Obviously, it shouldn't be some imposter or attacker. But that's no different than any other web service, whether it's synchronized or not. And so these are pretty much, regard them as solved problems to the degree that they're solved, and they don't really bother me. I do think it's helpful to have a strong security model for code here. Now, you can argue that you don't because you know the identity of the server, and so it's giving you presumably good data and so forth. But if this opens up and supports people plugging in or adding third-party stuff or add-ons and so forth, it might be a good idea to have some notion of doing something to make sure that this code isn't as evil as it could be. In particular, you might be thinking of things like Java or .NET, which both have this model of verifying the bytecode. And I'm not. I've been there, done that. So I think that you do want something else, but you certainly do want something, because real security is this process of jumping through hoops. And even though you're sure that one hoop is good enough, the hoops break for the oddest reasons, and it's nice to have a few extra ones to prevent total disaster from happening. So what are we going to do, since I'm not advocating, bytecode verification? The real point is that the wire format has to be dynamically type safe and pointer safe, right? Most of the really evil things that can happen if the verifier flunks in Java bytecode have to do with the fact that the bytecode itself is inherently insecure. So, just to take a random thing, JavaScript, the assembly language of the internet platform, that actually meets this criteria. There are much nicer things that you could engineer to meet them. JavaScript is interesting for the reasons you have made the world learn all too well. The other thing that I care about here is that objects have to be strongly encapsulated. What do I mean by that? I don't mean Java objects or C# objects. It's not objects where any other instance of the class can go muck with the fields of the object, or objects where anyone in the same package or assembly or whatever it is can muck with that object, or anyone's friends or anyone's cousins or second cousins twice removed. It's real objects that encapsulate their data. And no one can touch that data except that object itself. And the only way to change it is to ask the object through a method call to do it. That is the basis of what some people call the object capability model. And that's pretty much the idea here. We're actually going to use these objects as capabilities. How does this relate in particular to reflection? So I talked about mirrors briefly before. So mirrors are a technique that was developed by Dave Unger in Self many years ago. And I've done this in Strongtalk for the reflection in that system. There are parts of Java that use some of these ideas, not Java core reflection. That was done by people who weren't aware of that sort of work. And the point is that instead of having the reflective calls be calls on the class, so the typical model you get is any object will tell you its class, and then the class will let you query which methods it has. And if it actually has the capability for hot swapping, it'll let you change things and so forth, which means that once anyone has an object, he can go and muck with anything. The idea with mirrors is there's a level of indirection. There are specialized objects called mirrors that reflect other objects. So you get a mirror on a class. And you get a mirror from a central point, some server object, say capital mirror, that will produce a mirror for something if you ask it, and is in a position to verify who's asking. And for example, it might give you a mirror that only lets you introspect. It'll only let you ask about what methods the thing has, but won't let you change them. Or it might give you a mirror that'll let you change them, but only let you change a certain class, which may be your class or the class you own or something like that. So you can actually refine this in all kinds of ways to control who's doing what to whom. And I think that's the basis of introducing real security with real reflection and hot swapping at the same time. This is not something you can get from the traditional reflective APIs for the reasons I just outlined. Every object will tell you everything about it. It's not something you get from scripting languages where reflection is basically happening implicitly all the time. Reflection is you have a typo, and that introduces a new variable. So that is not really, in my mind, an interesting basis for anything secure. The other aspect of security that's related to this is you want a strong sandbox. You do want to control who's doing what. And again, capabilities give you a good way of doing that. And in particular, never, ever, ever have any global or static state. The security folks call this the principle of no ambient authority, meaning that there's things out there that are in scope that might give you the ability to do something. So an integer key might be one, but any object that had methods that could do something would be a good example of that. And so that's not a good idea. So security and sandboxes sort of bring us to the issue of modularity. And there's all kinds of reasons to use modules. So a lot of it is just for development, and some of it is for deploying stuff. And so let's talk about that a little bit. So a module, as I define it, is a self-contained parametric namespace. Self-contained means you can't refer to anything in that scope unless it is defined in that scope or is a formal parameter defined for that scope. You can't see anything on the outside. Everything has to come in explicitly. And traditionally, this was a bit of a problem because, in Fortran, that means you end up with a list of 50 parameters. But there are these things called objects that are very good at aggregating things. So you can basically get some sane number of things that are your handles on the outside world. And then you can build from there. In particular, these things do not have imports like, say, modula 3 or something. Imports don't decouple anything. All imports do, in the best case, in languages like modula, is they localize your coupling. So there's a panel that says where the cables are and where they're going to. But the analogy is, right, this thing is locked in. Right? If I actually do a modula 3 module representing this, I take it with a display, with a power cable, with a power station at the other end. They're all connected, and there's no way to actually decouple them. Right? That's not the analogy of a physical module or a hardware module. Hardware module has plugs that get plugged in. Java imports, by the way, don't even do that. They're just an aliasing mechanism. So that pretty much describes what a module is. And modules they're sort of like classes. They're instantiable. One of the things that disturbs me in a lot of these discussions is people confuse the definition of a module and an instance of a module. So a definition of any code had better be something immutable. Code should not have state, and static variables are one of the ways in which people really confuse that, and that causes all kinds of problems. So module definitions are immutable, and you can instantiate them by passing them these parameters, which themselves would be other objects instantiated from other modules, perhaps. And then you'd get a module instance, which would be a stateful object that you could actually run. It might represent your application as a whole, for example. And this has to happen somewhere. Of course, you have to bootstrap yourself. So there needs to be a namespace where you can see the global namespace. But the global namespace only consists of immutables. It's fine to have this namespace, this inverted internet domain name convention that Java introduced. One of the best things Java did, actually. As long as all the things you see there are immutable. As long as they're stateless, because global state is evil. And so in a scope like that, you can name different modules and plug them together and create actual instances that might represent something that does something useful and create a process of some sort. And so the parameters to these modules are objects that serve as capabilities that determine a per module sandbox. So this is just, the way, this is not a syntax I'd use, but it's a syntax that probably a lot of people are familiar with. So you can imagine that the way you actually start an application is by calling main, and you give it an object representing the platform. That's your actual link to the outside world. And then you name here com.foo.bar.demo would be the name of a module definition. You've gone, the global namespace is basically the internet namespace. Com is actually, if you think of it, an object representing the com namespace. And it has, for Google or Cadence or Sun or anybody, it has subnamespaces, et cetera. And eventually you get this thing, and you pass it these parameters, which will create an app. Now the parameters, in this case, say, would be a sandbox and some arguments that presumably are immutable here in this example, to be safe. And the sandbox is something you get from the platform. So there's different levels of trust, and you might ask for a particular kind of sandbox that represented the right level of trust. And maybe there are callbacks, so it has to get the app as a parameter. So that's why it's this letrec, right? These things are actually mutually recursive. And one of the deficiencies of most language module efforts is that they don't let you define mutually dependent modules. And this is, one of the litmus tests that I would apply to otherwise very powerful systems like, say, ML modules. So this is the way you'd actually get this object, and you could run it. Now, no static state, I've mentioned this, and let's just discuss it a bit. So modules namespaces are values, and it's good to have a concept of immutable values really worked out in your language, because then, for example, you might also use it for other things, like complex numbers, rather than having people complain for years and years and having to explain to them how complicated it is for you to actually do anything about their problem, which is what happens in some languages. So why not static state? It's good because if there's no static state, there's no static state to distribute. It's good for security for reasons we've outlined. This is a thesis of mine that I can't really prove, but my impression in the Java world was that the static state really contributed to the huge startup time problem. Java VMs are wicked fast. And every time people investigate this, they find, oh yeah, it's not our fault, the VM guys tell me. Yeah, we checked, it's doing X million bytecodes per second, and then it still takes 30 seconds. So there must be zillions and zillions of bytecodes being executed. Why are they being executed? Because the model that we give to programmers is set up the static variables for your class, which the minute you have one instance, that class gets set up, calling new objects, setting up their classes and their superclasses. And basically, you have to build the port of New York in order to land a canoe on Manhattan Island. That's sort of the net effect of it drawing in the whole world early. So if you don't have static state, it basically forces you to explicitly decide when things get initialized, hopefully lazily as possible, and sort of spread that pain out. People who I respect and who know about these things have told me it really helps their memory management issues. Because if the code really has no association with state, it's just other objects that you can garbage collect, and you don't have to necessarily be very fancy about dealing with them as a special case. I don't have time to tell you the story of Java class unloading, but it certainly is a real issue. So before I go into this, I just want to summarize and give you a picture of how all this stuff might actually be, in some sense, made real. So obviously, the way things are going, everything's being done on web browsers by shoving out JavaScript out to these browsers. And modulo the security concerns that I had about object encapsulation, which you might be able to work around with various solutions, you could imagine trying to implement something at this higher level on top of that, provided that there was something on the other end that could store objects. There was some object store you could talk to reliably and standardized and across browsers in some way that you could manipulate, and that had the right sort of API. For example, it would let you get at all the objects, because you're going to need, JavaScript is actually very flexible. It sort of can probably do the hot swapping effects by changing the right prototypes, et cetera. But you have to get at all the right objects, null out the right fields, et cetera, et cetera. And basically, if that basic extra machinery was there, then people could compile a decent language into that. And that might just happen someday. It would also help if JavaScript was faster. Somehow, I have the feeling that these problems will work out in time. So this concludes the sane part of the talk. You might not have noticed. But now let's talk about some really fun things that can happen if you start taking this story seriously. And this is usually where resistance heats up. So what do I mean, no versions? Versioning, every module system that's serious talks about versioning and gets into no end of problems, and the wounded are here to testify if necessary. So I don't really believe in versioning. It's a rat hole. Nobody's ever solved it. Nobody ever will. What I'm actually saying here is you have this service. People are subscribed to it. They get the updates and fixes on every sync. And they see only one current version at any time, just like a web page. You know what? I really liked that web page you had in 2003. But I can't get the Google web page version, whatever it was, from 2003, right? There's no such choice. People don't even think of it, so they don't pester you about it. But, right, that's very nice that there is, from the user's perspective, there's only now. And I'm going to take this further and argue that you really get away from releases. Of course, every time you put out a patch or something, there's a release. But in fact, you get away from these things where there's update releases every 6 months and big releases every 2 years or 5 years or whatever it is. The bigger the system, the more horrible it gets. And this is the thing that's kind of out there. So am I serious about this? This is a huge change to any development model that people have. OK, so it's relatively easy for applications. You've sort of shown that it works for applications. Now, relatively easy, I'm sure enormous amounts of work. Shut up, machine. Go into this. But the interesting thing is, what if you pursue this further and say, let's do this for libraries and components? So applications, if you change an application and something is somehow a little bit broken, well, as long as there's a human in front of it, they're relatively adaptive. Even executives are. And the difference with libraries is that they're very, very brittle. It's just code. And if some little assumption, possibly unstated and unrealized by anyone, changes, suddenly the whole house of cards just collapses. Which is why people fanatically try to nail it down and say, we're using version so-and-so of this and that, and you have build systems that are just trying to get the right thing, and enormous amounts of effort are expended on these horrible, horrible things. So I'm proposing to do away with that in some sense. Again, developers are subscribers to the library vendors, just as the people in front of the machine were subscribers to the application vendors. And they sync up. They get new versions of the library. And they get this continuously all the time. And that means that things are changing really, really fast, right? It's not about updates every 3 to 6 months and major releases every 2 to 5 years. It's about days or weeks, or for a really large system, maybe it's a month or a month and a half on the outside for completely going through the cycle. And this requires a total change of mindset from the people involved, and which is why it'll take a long time for this to happen, even if the first part does, because basically you have to shoot all the developers and wait 30 years till new ones grow. I mean, this happens. We've seen this happen in the past few years, say with IDEs. The VI programmers, they're getting arthritis, and finally we're getting people to use IDEs. There are all kinds of things that people told me wouldn't happen. They happen. You just have to wait them out till they die or retire. And so basically, if you're in this mindset and you're prepared to actually deal with things, there are advantages to that. It's a little more like open source. The bits are going to rot on you all the time, and you just deal with it continuously. It's also a lot like, say, homework at school. You can procrastinate, which is what I always did, and cope with it somehow at the end. Or you can actually be good, which no one really does, and do it all the time. It actually is easier if you do it in little increments like your teacher said, but you need a discipline. The difference is this isn't school. People get paid to do this. And I'm arguing that this will get you better software. So how would you actually make this work? Well, you can look at it from the perspective of the people producing library code. From their perspective, actually, just if you're thinking usually the producer and consumer, you're both a producer and consumer, of course. But assuming that you're looking at it from the producer side, it's great. You can deprecate a method. You decide this thing is a piece of misdesigned crap that we came up with in a hurry, and we really should get rid of it. And the difference is deprecating doesn't just say, put on documentation, please don't use this stuff, and it'll live forever anyway. It means we're going to get rid of it. We're going to get rid of all this bloat. We send out a notice. We know who our users are. Everybody is on the server. There's a network out there. It's not like you have users out there who you don't know who they are. You can find everybody, and you can notify them. This method is going away in 2 weeks' time. Here's the refactoring script that replaces a call to method X to method Y. If you don't fix your own code by 2 weeks' time, your code will break. And if you want to be really aggressive, you know what? The server will run the script and refactor it for you. That's getting really radical. And there are, of course, legal and privacy issues. This sort of works better in an open source kind of model, sad to say. But basically, you can do senders of all the callers. You can find whoever's calling this thing and find out. And if somehow there are things that are much more subtle than that, right? You have a method, and it's spec'd to return nil under some circumstance. But it doesn't really, because someone hacked up the implementation really quickly. But now you find out that to do the job properly, it really should do that. Unfortunately, now it's already been released, and you don't know who's out there depending on this particular behavior. But you can still find who the callers are and let them know. And you know what? If it breaks, again, in the development cycle, you'll find out, because all your developers are tied to this update cycle, and they'll let you know. And if it breaks anywhere in the world, you will know. Which is very different from sitting inside Java and saying, oh God, this is terrible, but what can we do? Who knows who's using this? Looks obscure. Let's try and see if we can get away with it. Not that we'd ever do that, of course. Now, from the consumer side, if you're on the receiving end of this, it's a good deal harder, right? Now, someone's changing this stuff while you're trying to work and develop, and someone's meddling with this library as you're doing this. Now, the one thing to remember is that the pace of this is actually managed, right? Today, you decide at some point, we'll go to Java 5, and 2 million lines of code have changed, and everything's different, and it's a huge step. Whereas here, libraries don't actually change every day, right? This week, oh, they've taken away this method, or whatever. This is a pace that maybe you can manage if you stay on top of it. The other thing is, okay, they changed something, and now you have to adapt to it, and there's the old version that did this and the new version that does that, and you start ending this crufty code. Well, if it's like this, do this, etc. People have this in their code everywhere. And the problem is that these cases live on forever and grow from version 1 to 2 to 16. Here, basically, these things live a week. You have to put out the test because you might put out your fix before they put out theirs. And for a little while, you might encounter inconsistencies. But once they've put out theirs, you know that all the data has actually been converted. And you'll never encounter this case again. And you can clean up your code. You can reduce cruft. And I think this effort is worth the value because it changes from a model where things are compatible to doomsday, and you end up with Vista, to something where you can actually clean it up as you go along and actually do good programming. And of course, you're going to make mistakes and put out bugs there that the real users will see. But you know what? You're doing that anyway. And today, sure, you go to a lot of testing to avoid that. But when you put it out for the users, what happens? Well, they can write and be annoyed. And they can wait. And if they're lucky, in 3 months, there's an update release if your update release cycle is rather rapid. And if it's a high enough priority bug, that is, a lot of important people have complained, et cetera, or they can wait 6 months, or they can wait 2 years if it's not a high priority. It'll be fixed in our next release. Thank you very much. You may actually have more bugs put out, but you can fix them tomorrow. You can actually respond. You can fix if anyone complains. In fact, if they don't complain, you don't have to put this little window that Apple puts up. Would you like to report this bug? It gets reported anyway, because it's all on the server. You can put asserts in your code that write an object to the server that said, this thing is not right. There's all kinds of interesting traceability and things that people could do in this framework, and I'm sure I'm not clever enough to figure them all out, but you probably are. So I think that this is a huge mindset change, but I argue that it'll give us better software in the end, and the current situation is just untenable as these things grow bigger and bigger and bigger. And even if even if you are the recipient of the global software tax and have untold billions and thousands of developers, it gets to the point where you can't deliver anything remotely on time. And you can never deliver anything secure. So that's most of the technical content here. So a little bit about related work. Well, mirrors I've talked about. This is where they come from. So I've done that. I kibitzed on this. This is the Java debugging interface, not the reflection. APT is this annotation stuff. There's a paper in OOPSLA 04 that I wrote with Dave Unger that actually describes mirrors in some detail and argues for some of their other properties, the good software engineering properties, et cetera, that they have. Idea of not having statics, you can see that to some degree in Scala. In E is a very interesting language that sort of is actually focused on security issues. And of course, there's security lessons to be learned from it and from Java, positive, negative. Modules, there's all kinds of works on modules. This is my thesis from 1991, which may still find its way into this scheme. Units is very close to what I described as stuff that was done in Scheme. Very nice work. ML modules are sort of the standard academic reference for modules, but they have very significant problems in my mind, despite being very powerful, particularly no mutual recursion and the fact that they're not first class. Fortress has a component model that's kind of reminiscent of this. Didn't really talk about representation independence this time, but one of the things, okay, so the point was when you had the transient fields that have to be lazily initialized every time because they get zapped, well, it really helps if everything goes through an accessor. Now, any decent object-oriented language should make sure that everything always goes through an accessor, and you won't be able to tell what the actual literal representation underneath the object is. Self pioneered that idea. Some of this, especially the early part of the talk, relates to the various client work, rich clients, thin clients, fat clients, smart clients, managed clients. I've heard all these names, no end of efforts. Flash, the macro media were actually some of the people who were really on this very early, but their business model was interesting. They wanted 20% of developers' money. It didn't work out. There's, of course, all kinds of stuff. You know more about this than me. SyncML, WebDAV, all kinds of things that SyncML is interesting for the synchronization procedure, actually. So sort of the big language technology picture here is you need object-based encapsulation to do an object capability model, which gives you security, which is necessary to really do hot swapping in production. The other thing that is really practically necessary and very helpful to be able to do it is dynamic typing. Once you have hot swapping, as I said, you get the software services, and there is nirvana, version-free software someday. So to summarize, this is my slogan. The idea is that the indestructibility of bits is actually a curse in disguise. It's not a feature, it's a bug. And we are better off with a model that expects change and incompatibility as a matter of course, rather than a model that says, oh, hang on and try and make it work the same with the same old cruft forever and ever. And using some fairly basic techniques from dynamically typed languages that do have features that you don't really find in practice yet in like modularity and security, based on the object model, you can actually construct a model of the world that actually works this way. So there, that was it. Thank you very much. And if there are any questions. Yeah.
So this model requires all software to be available online to everyone?
All the software that's being delivered by, oh yeah, I got to repeat the question. You'll have to remind me every question. So the question was whether this requires all the software to be freely available online all the time. Is that right? It requires that all the software that you're delivering through this service is on the server online and available. I didn't say, whether it's free or not is a completely, that's a business model question. There are real issues, of course, with what exposure. If you want to do some of these things, am I willing to let you know which calls I'm making? And to what extent can you do that? And there may be intermediate degrees. If it's open source, that's a non-issue. If it isn't open source, your contract has to say that, if you're using my library, I agree to let you know which calls I'm making. I may not expose all the code, but I'll tell you that I'm calling these particular routines and maybe this number of times. There are intermediate degrees. But yeah, and really it requires that you be writing in a high level of a language that actually enables you to do the sync. That's the real hurdle. Robert?
You were mentioning that you want to get rid of releases, but aren't you just shortening the release cycle? Like
Yeah,
to like an hour or something?
yeah, well, yeah. Am I lying about getting rid of releases because I'm really just shortening the release cycle to maybe, if I'm lucky, an hour or a week or something? Yes, I am, but that's a lot less painful than, you can't have a lot of meetings during this hour, for example. You can get rid of all kinds of bad things about releases, the process, the committee, But yeah, we are just shortening. There are still versions. There's a developer version, possibly multiple versions, and there's the real version out there. But people don't see the versions, and the number of them just decreases a great deal. Yeah?
How do you typically evolve the persistent state? It's like, say you can replace one object with a different.
Okay, so how do I evolve the persistent state if I've replaced say one object with a group of objects? So let's start with if I've changed the shape of certain objects, right? You can go through the heap. This has been done. People have come up with you can define a script that massages old data into new data. If it's multiple objects, presumably, hopefully they're hanging off of something that coordinated them, or they're in several data structures that several tables that and you go over them and you basically reconfigure that data structure. You make a copy of it, and these objects are lying in this persistent store on your server. And maybe you sometimes will have to do this in stages. So you'll instrument your code to update both of these structures and then swap, right? But you can do this over like 2 cycles of synchronization or something. Yeah?
So if an end user has an application that they've gotten through this model that they like, that employs a library that's also using this model, if I understand you correctly, then I'm now on the hook for continued maintenance of both of the producers.
Okay, so the question was, we've got a user who's using an application that they got through this mechanism, and that uses a library that is also available through this mechanism. And am I, and my question is who you meant by I, but who's on the hook for continued maintenance of both these things?
An executive.
An executive, okay. So the executive presumably works for the software vendors, right? So yes, anyone who's participating, who's a vendor, who's providing code through this model is on the hook for maintenance, essentially, as long as they want to be in business with this model.
So, but if an end user is using the application,
Mm-hmm.
and then development on the application ceases, but development on the library continues, then it seems like I'm in a position where my application may stop working.
Yeah. Yeah.
No,
Right. Okay. So you contract the user is getting a service. We haven't really business models, or one can speculate, but the service, if you are providing an application, then you probably have a strong interest in as a service, making sure that any application that you're putting out there is maintained. So if the people who contract, so you probably want to contract the applications and make sure that they have some obligation to you to maintain this, and if not, that you own the code and maintain it. And you know what? Sometimes that application will go away because maybe there are not enough people who make it worthwhile to maintain that. That's the difference between software as an artifact and software as a service. Software as an artifact is something you hold in your hand and keep it for as long as you possibly can. A service is not something you hold in your hand. If you go to a restaurant and it closed, tough luck. It's my favorite restaurant and they really shouldn't have closed, but damn it, they wanted to retire. So I can complain, and in fact here at least I can complain to somebody because the service there are issues of managing it yet, but some of these things may go away. And at that point, we've discontinued the service for this application, and you might have valuable data, which we will give you in XML or whatever files, or you probably want to have some contractual obligation to get the data. But yeah, there are no guarantees in life. In reality, people use applications from if they're serious about stuff, they use application from vendors who they know aren't about to go away. That's what distinguishes a serious vendor from something else. So you're getting a service. You're not buying the thing. Michal?
So developers in this world use many different libraries, and they all have very frequent update cycles.
Mm-hmm.
Do you worry that all the developers become slaves to maintenance and have no time for creativity while adding new features or whatever?
Well, if I were a developer, I'd worry that they become slaves regardless of their creativity. So the question is, do I worry over the fact that in this model with these frequent updates, the developers become slaves to the maintenance and upkeep and don't invest any creativity in doing cool stuff? So I think first of all, there's a worry about the developers, especially the small scale individual developers, right? You're sort of online here all the time, right? If you're a small business owner, you'll find that this isn't new in the world, right? If you want to make your life vaguely tolerable, it's really good to have a partner so you can take weekends off or something and share time. And pair programming, for example, goes nice with that. Maybe you don't want to be the only one who's maintaining this thing. There's a cost to maintaining things at this level and maybe 24/7, and there's a question of whether people are willing to pay it. Not necessarily the developers. There may be an economic model here where the service actually, if you can still get someone to pay for it, to pay for the storage, to pay for the backup, etc., where they actually have an interest in paying the developers to maintain this. And so yes, they could become slaves because someone has to keep the thing, but that's especially an issue with smaller groups and more bigger applications. There has to be a team that maintains it. The creativity, the model where we buy software from someone who sells it has not shown me software with great creativity that I'm not worried about that. Yeah.
So does the lack of static typing make it more difficult for API consumers to deal with changes from API producers? So how do you mitigate that?
Yes. So typing is a double-edged sword. The question was whether the lack of static typing made it harder for consumers to deal of APIs to cope. It actually makes it harder for the producers as well, because one of the things that's harder is to find out, in a dynamically typed language, it's not so clear who is calling your method and not some other method with the same name, right? So static typing of some form is actually very helpful. It's like the IDEs that do name completion and all that. They can do a better job with some form of typing. It's a different talk to talk about optional and pluggable typing, because really this is about the documentation value of typing in some sense, which is the main value as far as I'm concerned. And that doesn't depend on having a mandatory type system. What mandatory type systems tend to do is to encourage people to implement very brittle systems that break if any of those type assumptions broke. And with all these updates going on, there's another story here that you could say it is statically typed, but we actually do cope with the hot swapping by having the server verify that everything is type safe before we give you a download. I don't like complicated. So I don't necessarily advocate that, but who knows how this might evolve in practice. But it does make it more difficult, and it would be nice to have at least optional typing to give you some handle on that. So we're after 3 o'clock. There actually is a meeting room if anyone actually wanted to talk about this more, Gainesville. But maybe nobody wants to talk about it more, which is fine. So.
You mentioned the building.
Oh, a building. Oh, yes, you have many, many buildings. It's in building 41.
First floor.
First floor. There, I think I passed the quiz. So if anyone has further questions, I'm happy to entertain them here or there. If not, thank you very much for coming.